right, here comes one of my favorite lessons, which is Unit 3, Day 2, otherwise known as polynomial division. And there's actually 3 ways to divide polynomials, and we'll spend a day on each of them. So your notes today are on polynomial long division. Polynomial long division is probably my favorite way of doing it, even though it's kind of the longest and more arduous ways of doing it because it works every single time. There's going to be something called synthetic division that we'll do a little bit next class, but that one you can only use under certain conditions. And then there's division by factoring, which again only works if both polynomials are factorable. So the reason why we spent some time doing long division is because we are going to follow the exact same algorithm or just kind of enhancing it to follow some polynomial looks here. So the first thing we're going to do is set it up. So here I'm dividing by x minus 5. I'm going to zoom in on this a little bit. Okay, so here we have a problem. We are going to start by dividing x squared minus 2x minus 15 by x minus 5. And the way we're going to do this is that we are going to take our first, our leading term, and we are going to divide it into the first term of the polynomial. So I can see here that x goes into x squared x times. Okay? Goes in x times, and you can just see that I'm kind of lining this up so that these are going to be in a nice column of x's, and then we're going to also have like a column of constants. All right, so we'll try to keep our columns straight as we go along. But anyway, x goes into x squared x times, but we are going into the whole thing x minus 5. So to figure out what goes underneath, we want to do x times x minus 5, which is x squared minus 5x. And just like in regular division, we're going to subtract. So I should get a 0 in this x squared column, and I'm going to do negative 2x minus negative 5x, which is a positive 3x. Now again, I'm going to ask myself, how many times does x go into 3x? And x goes into 3x 3 times. Now I'm in the orange column because these are my constants. But in order to figure out what I'm subtracting by, 3x minus 5, I want to do 3 times x minus 5. So that was 3x minus 15. If I pull that down, and that's 3x minus 15 when I multiply back through, and I get a remainder of 0. So my answer is just x plus 3. You might be thinking that that looks like a lot. So we'll go through and we'll do another example. I'll try to do that one all color-coded for those of you that that's going to work with. And then when we slide down to example number 5, I'll stick to one color, and maybe you can just look at it for the algorithm as it is. So let's scoot on over to number 4. All right, I'm going to set it up. I'm dividing x squared minus 9x minus 10 by x plus 1. We can think of this as having a few columns. We have our x squared column. We have our x column. And we have our constant column. Okay, that's just the first thing that I'm going to do to try to organize our thoughts here. So what I'm going to do first is ask myself, how many times does x, because that's my leading term, go into my other leading term? And the answer is x times, because x times x is x squared. But I don't want to just do x times x. I want to do x times x plus 1. X times x plus 1 is x squared plus x. In division, we subtract. So x squared minus x squared is 0. That's nothing there. And negative 9x minus x is going to give me negative 10x. So now you want to ask yourself, well, how many times does x go into negative 10x? And the answer to that is negative 10 times. Okay, so you bring down, we always bring down the next term. And then I want to multiply my negative 10 by my whole term, and I'm going to get that that is negative 10x minus 10. When I subtract, I get 0, so this is remainder 0. So you can see here, I get x minus 10 as an answer. So let's compare the two. Both times, I got 0, which gives me a remainder of 0. And this time up here I had x and 3, so I put them together with a plus sign. And over here I had x and negative 10, so instead of writing x plus negative 10, we're just going to say x minus 10. All right, let's see that process all together. And this is also going to be our last example where we have a 0 remainder. And all that means is that x plus 1 and x is a factor of x squared minus 9x minus 10. And that means that x minus 5 is a factor of this one. So this one looks a little different. You know, division problems, they look like 3 divided by 2. They look like 3 divided by 2. And they also look like 3 divided by 2. So they can be all over the place. And with polynomials, it's no different. But let's go through number 5 together. All right, number 5, we have x squared plus 9x plus 14, and we're going to divide by x plus 7. I'm asking myself how many times x goes into x squared. And it happens to go in x times. And then I'm going to multiply by what's on top, by what's down here, by the factor that we're dividing by. And I'm going to multiply that, and I get x squared plus 7x. Division tells me that I want to take the difference, and I'm left with 2x. I'm going to drag down my next number, and now I'm going to ask myself, well, how many times does x go into 2x? And it goes in positive 2 times, so there's my plus 2. And now I'm going to multiply 2 by the entire factor I'm dividing by, and that gave me 2x plus 14. So when I subtract, I get a remainder 0. So my answer is x plus 2. And that makes sense, right? Because look, if I got x plus 2 as my answer, I was dividing by x plus 7. If I were to FOIL this out, I get x squared plus 9x plus 14. And therefore, I proved my division. Because division is just the inverse of multiplying, right? Right. Okay. But what if it doesn't go in perfectly? What if we have a remainder? So let's look at this next situation. Okay, I'm going to write it out. This time I have 4 terms. Same process, 4 terms. 3x squared, 3x cubed, minus 5x squared, plus 10x minus 3. And that's going to go into 3x plus 1. 3x goes into 3x cubed, x squared times. And I know that because x squared times 3x is 3x cubed. X squared times 1 is just x squared. Same process as before. What does the first number go into? Multiply that by the whole factor. When I do this subtraction here, I am going to get negative 5x squared minus x squared. I get negative 6x squared, and I bring down my next term. I ask myself, how many times does 3x go into negative 6x squared? And the answer would be negative 2x times. So I'm going to multiply negative 2x by the whole factor 3x plus 1. And I get negative 6x squared minus 2x. Remember, we're subtracting everything here, so I'm going to get 12x. Here, and I'm going to bring down my next term. How many times does 3x go into 12x? It goes in 4 times. 4 times 3x plus 1 is 12x plus 4. All right, this is where I can start to see some trouble because negative 3 minus 4 is negative 7. So this one has a remainder of 7. And there is a certain way that I want you to write this. I don't want you to leave it like this. We want to kind of summarize our results. And if we were going to do that, I don't really have a great place to do it. I'll do it above here. If I want to give us the final answer, we're going to write that out as x squared minus 2x plus 4. And then 7 is positive, so we're going to do plus 7 over 3x plus 1. Okay, and that has to do with the explanation of remainders. If we had remainder 1 and we were dividing by 2, we would usually turn that into the decimal 0.5. So that's where that's coming from, the fraction. And 7 is the thing that was left over when we divided by 3x plus 1. We have 2 more on here, and one more on here, and I want to show you what I mean by a placeholder. Okay? A placeholder is just because we want our degrees to go down in descending order, 3, 2, 1, 0. Sometimes it's possible to divide without one, but it never hurts to have one, and other times we get it completely wrong if we don't put that placeholder in there. So we want to make sure that we're rewriting this, that we're dividing 2x minus 5 into 2x cubed minus 9x squared plus 0x plus 15. Your placeholder can go anywhere. In this case, we needed it to go here between our x squared term and our constant term because we didn't have an x term. All right, let's go ahead and do this multiplication. How many times does 2x go into 2x cubed? X squared times. Multiply x squared by the whole. We're going to get 2x cubed minus 5x squared, and we subtract negative 4x squared. And then I bring down my next term, which is my placeholder. How many times does 2x go into negative 4x squared? Well, it goes into it negative 2x times. Multiply negative 2x by 2x minus 5. And I'm going to get plus 10x. And I'm going to subtract. So I'm getting negative 10x. And I'm going to bring down my plus 15. 2x goes into negative 10x, negative 5 times. Multiply that in. Negative 5 times negative 5 is positive 25. But I'm going to subtract, and I'm getting remainder negative 10. So I'm going to combine that answer to be x squared minus 2x minus 5 minus, because it's a negative 10, 10 over, this is the fractional part, 2x minus 5. And that's how I'm going to expect you guys to leave your answers. So this is definitely a case of practice makes perfect. And I just want to show you again how we have these nice columns. We have our x cubed column. We have our x squared column. We have our x column. Oh, that looks like the same color. We have our x column, and we have our constant column. And really keeping these columns straight is what's going to progress you as you go through, and really make sure that you're keeping your numbers where they're supposed to be. So these are your first 5 examples of polynomial division, polynomial long division, because there are 3 ways to do polynomial division. I hope you like it. I hope you find it interesting and see how it's the same algorithm as with regular division. We'll do lots of practice with this, and then I'll show you the other 2.